Okay, good morning. This seminar will be basically focusing on the basics of testing. So I will be taking you through like what is testing, why we need testing, and also few tips and tricks about this particular process, which is very important part of a software engineering process. So you might be asking me like why? Why do we need to know the basics of testing? We are already testers. We might be having few people who are here who have been into the field of testing for the past 2, 3, 4 and number of years. But why do we need to go through the basics? Basically, there are two reasons. One, sometimes in the course of time, we do the very silly mistakes and we miss the fundamentals. That is one reason. The second one is we need to brush up sometimes. The old things need to be brushed up. Okay. So here in this presentation, I'll be taking you through that very basic journey of testing. But yes, I hope you will be finding it helpful by the end of the session. Okay. So my name is Sudeep Pattnaik, and my job is to test software and find bugs. I call myself a tester. Okay. I have 7+ years of experience in software testing, and currently I'm working with Mindfire Solutions, as all of you know. And I have worked on domains like BFSI, CMS, and healthcare. So in these past 7 years, I have seen a lot of people who have been into the field of testing. They have been innovating every day, but still they need to stick to the fundamentals. That is the reason brushing up the fundamentals and knowing the testing fundamentals is important. Okay. First thing, let me clarify a few of the misconceptions which you will be seeing in the market very frequently, told by someone, told by your friends, told by your colleagues, told by your friends who work in different company, told by your friends who work in the same company, told by your friend who works with a different domain. So the first misconception is software testing provides jobs on short-term basis, project over, job over. Do you think so? Any of you? I do not think so. Because generally what happens, people who tend to talk these kind of things, they have not been into actual testing projects, or they have been assigned with testing projects which are of short term. And after that, they are again out of testing. As far as my knowledge is concerned, as far as my experience is concerned, the day on which you will be having anything developed, might it be a software, might it be any other thing, testing will be there. You will be finding testing in each and every field of any kind of development. It might be a service, it might be a product, testing will be there. Okay. The second is, in the long run, no guarantee for careers. This is another misconception. People think if I am a tester, my career growth will be stagnant. But let me tell you, testers are better managers always, because generally what happens, testers, they have to know the complete flow. They have to know the product completely. They have to know the application completely. That's why it's their job. It's not like they are bound to know. It's their job. They have to know the application thoroughly. Then only they can test it in a better way. That is the reason testers have guaranteed careers. If you are a tester, definitely you are going to have a career which will take you to the topmost place possible. Testers are given less importance than developers in the industry. Again, this is one of the biggest misconceptions. People think like testers, they are given less importance, but that is not true. Always, whatever anyone does in an industry, it might be a tester, it might be a developer, it might be a scribe. Scribe is someone who writes down the things. It might be a technical writer, it might be a designer. Everybody have their own importance, and all are having equal importance in this field of software. If one person is gone, you cannot go ahead. If a designer is gone, you cannot come up with the designs. You cannot get the layouts for your projects. If a developer is gone, you cannot code even if you have the design. If you do not code, if you do not have the design, you cannot test it. So without developers and designers, your thing cannot go ahead. If a tester is gone, no matter whatever things you have designed, you cannot quality assure it. Right? So every job, no job is having less importance. Every job is having equal importance in the field of IT and software. I can never be a manager if I am a tester. This is one of the biggest misconceptions. But testers are equally potent to be managers and they can be good managers too. Because as I said, the testers need to know the complete flow of the application. They need to know the complete functionalities of the application in order to test it in a better manner. So a good tester can always be a good manager. A good tester can always be a good business analyst. You know what is a business analyst, right? A business analyst is a person who analyzes the business and prepares the requirement specification sheet. Okay, so tester can always be a good business analyst, that is a BA, or a good manager. Okay, anyone can do testing. Do we need to be qualified for that? Here, what matters is how you look at the application and how you innovate yourselves to do testing in a better way. Okay, testers are paid less compared to developers. I think people working with Mindfair will not be having this doubt. Okay, opportunities are less for testers in the market. This is one of another misconceptions, because as I said, each job is equally important in the field of IT and software. Testers always have jobs. Okay. The next thing is, what is a software? Can anybody tell me what is a software? A collection of programs. Then anything else? Okay. A collection of programs with a good UI. Okay. Can anybody compliment?
The quality also matters.
Yeah. Okay. Exactly. It's a piece of, so a software is nothing but it's a combination of everything. Good quality code, which is meant to deliver a particular task. Like you said, it is meant to perform some specific task with a good UI and also with a good quality. And who assures the quality? The testers. Okay. What is testing? What do you mean by testing?
Process of finding whether the models are working properly, the interaction between models are correct or not.
Okay.
And is there any bug?
Okay. So you mean to say it is the process of finding bugs. It is the process of finding whether the modules are interacting with each other properly or not, and whether the application is designed to deliver what it is expected to deliver or not. Okay. What do you get from these pictures?
Breaking the code, trying to do a
Okay. So this is an overview what software testing is all about. Okay. We also write scripts in software testing. Like, you know, we use different tools like Selenium or Ranorex or QTP, whatever tools we use, we write scripts to automate the softwares. Also, like you said, it is one of the biggest things that we cover under software testing is finding bugs, finding flaws in the application. And the next one is, you can see a robot is holding a lens kind of thing. It is actually checking the quality, like whether the software matches the expected things or not. Okay. And the fourth one, the most important thing, as a tester, you should always try to break the application. Okay. By breaking, I don't mean literally take a hammer and break your application. You need to try different approaches. Here, breaking should not be taken in a negative way. Here, breaking should be taken in a positive way, because you are breaking the application in the testing phase so that it is not broken by someone else in the production. It is much better to get the flaws in the testing phase than to get the flaws by one of the customers. Okay. So by breaking the application, we make sure, I'm sorry, we make sure the application is completely bug proof. Okay. Means you cannot say always like the application is completely bug free, but yes, it is mostly bug free. We will come to that other part where we will be talking about exhaustive testing, why it is not possible, etc. But yes, at least we should not be missing out normal bugs. It should be free from normal bugs. Okay. Now let's come to the thing, what is software testing? It is a process to check whether the software matches the user requirements or not. The main thing or the main aim of software testing is to check whether the application matches the requirement specification properly or not. That is the very first thing that we need to do under software testing. Okay. In the testing process, the testers try to find out whether any bug exists in the code or the application and whether the application is working as expected. In short, we can say that the testers assure the quality. How can you say the product is a good one? How can you say the product is a better product than any other product, similar product available in the market? By assuring the quality, you will be telling, yes, my product is performing good under this much amount of load. My product will be supporting this many number of browsers. My product will be working fine with this many number of platforms. My product will work on mobiles. My product will work on desktops. My product will work on tablets. Okay, so these are the things how we can make sure like these things are assured through quality assurance only by testing the product or only by putting the product through a testing process where we will be testing this particular product under all possible platforms, under all possible scenarios, under all possible under all possible devices possible. Okay, is testing really important? Answer, a big yes, it is important. You cannot go ahead without testing. Why you cannot go ahead without testing? Because generally what happens, let's say you people are designing something, okay, a developer designs something. It's a normal human tendency that somebody who designs the thing, it is difficult for him to find issues or bugs in his own creation. That is why testers are in place. That is why testers play a bigger role, because you are actually finding flaws in someone else's work. You might think it's a dirty job, you are pointing finger at someone else, but no, actually you are helping him, because it's normal human tendency that he may not be able to find out errors in his own work. So you are helping him find the errors in his work so that he could fix them and deliver a better product. Okay, that is why testing is important. Why? We discussed why testing is important. Reason one, I'll be giving you few examples which will show you that testing is actually important and how critical the testing process can be. Means without testing, what are the hazards that those can happen? Okay. Anybody have heard of this Ariane 5? In 1996, an European Space Agency, they have launched one satellite. It is called Ariane 5. There was a design error in the software design, and just after 37 seconds, that particular rocket, that particular satellite, it blasted itself. And why the self-destruction system was triggered? Because there was a computer bug, or there was a bug in the program. Okay, so you can see the self-destruction system when high aerodynamic forces cause the core of the vehicle to disintegrate. Actually, what happens when satellites were launched? Generally, what happens? They have different parts associated with the satellite. The complete rocket doesn't go to the orbit. It has to dismantle different parts, and only the final satellite goes into the orbit. So there was a small bug in the software code. So after 37 seconds, the rocket blasted itself. It is one of the biggest disasters in the history of US space history, causing US dollar 370 million. There was a loss of $370 million only because of a small software bug. If that would have been tested properly, then easily this mission could have been saved, as well as they would have also saved those 370 millions. Okay. Next, the Patriot missile. Anybody knows what is a Patriot missile? It is the missile which kills missiles. Like somebody has launched a missile on you, you can use a Patriot missile to prevent the missile attack. Okay, it destroys the other missile, the incoming missile in air. Okay, during the 1999 Gulf War, Iraq attacked American barrack with a missile. Okay, so US used its Patriot missiles to destroy those incoming missiles. But due to a software bug in the program, in the launching program, it was not able to get to the missile correctly. So it was hit by the missile, and also a lot of people, a lot of soldiers were killed. Reason? A software bug in the Patriot missile code. Had that been tested properly, they would have saved lives and they would have destroyed the missile correctly also. Okay? Reason 3, the Great Canadian City Scanner. Anybody knows about this incident? There was a hospital in Canada where there was a CT scan machine. After a particular number of scans, the patient used to die. Nobody knew the reason why the patient is dying. Everybody tried to find out the reason why the patient is dying. Means once one patient will die, then after few patients, another patient will die. After few patients, one more patient will die. So it was later on found there was a software bug in the program of the machine. So what happens, after some scans, the machine used to reset itself. And that resetting process used to be for a very short span of time, let's say some seconds. But if any patient is inside the machine at that point of time, in that particular short span of time, he was exposed to a huge amount of radiation. CT scan is nothing but radiations, radio waves. So those radiations were uncontrolled. So they lost their lives. Okay, so it was also a bug in the software. The Great Bank Robbery. I guess all of you have heard about this. Like a US bank, one employee, he has programmed the code in such a manner, like the amount, like generally what happens, you have your savings in the bank. So after some time or once in a year, you get your interest credited to your account. So that interest is counted in decimal numbers. Let's say you do not get whole numbers every time, right? You get, let's say 100 rupees is the interest, then your interest amount will be something like 99.27854321. So what he did, he programmed in such a manner that the last 4 digits after the decimal, that 0.0002731 is credited to some other account. It might be very less because you will not be noticing it, thinking like, yes, I don't care about those 0.0002731 paise or 0.002731 cents. But if you are collecting that much amount from thousands of people, then you are a millionaire. That's what he did. And he intentionally did the programming like that. And he was not caught for more than 8 years. Yes. And he was only caught when he tried to withdraw all his money at the time. He withdrew all his money at a time. And at that point of time, the police got suspicious and he got caught. So had that particular program been tested properly, this would not have happened, right? Somebody would not have been able to do fraud in such a manner. So these are basically few of the reasons why, these are basically few of the classic examples why we should go for software testing, why software testing is important, okay? Now, reasons for software failure. The first reason is people. The people who are working on this particular software, they lack in quality consciousness, lack of proper communication, and lack of interpersonal skills, and also sometimes professional ethics. The last example was a classic example of professional ethics. He programmed in such a manner that the money was credited to his account. So all these things result in software failure. Technology. Sometimes focus shifts from user requirements to technology. Excessive inclination towards new technology, it might lead to software failure because you do not know what exactly the new technology, like how it would be, what effects it will be on your application, on your system. Without knowing that, you get inclined to that new technology, and that results in failure of software. Time. This is something which we all would agree. Sometimes what happens, due to meet deadlines in a very less span of time, we do not test applications properly, and which leads to failure. Money. At the time of estimating the project cost, sometimes the calculations go wrong, and in turn it results in a failure. This is something which is a risk. You need to calculate your risks properly. Okay. Then you might ask, what is testing and what is debugging? So testing is done to find out the defects, whereas debugging is done to find out the cause. All of you might be knowing RCA, root cause analysis, right? Debugging is a part of RC, root cause analysis. So testing and debugging both are different things. In testing, you find the bug, but in debugging, you find what caused the bug. Okay? See, what I would say, up to a certain extent, testers can also debug. Like if you are writing a QTP code or if you are writing a Selenium code, you can very well use breakpoints and you can debug. But for that, you need to have access to the code. Okay, if you have access to the code, generally when you are writing a script, you are having complete authority over your script. So there you can see what error happened as per your script. But to find what thing caused an actual functional error, you need to have access to the code. In that case, you need to talk to the developer who will be helping you with debugging. And if you do not have that access, then definitely you have to just pass on the bug to the developer and he will debug it. Okay, clear? Difference between error, bug and defect, I don't think we need to discuss it in more detail, because we all know error, it's a deviation from logic, syntax or expected execution. Okay, you can have syntactical error, logical error and execution error. Bug is inconsistency between functional requirement and actual implementation. It is found during the testing process before the product is delivered to the customer. This is the basic difference between a bug and a defect. A bug found after the delivery of the product is called a defect. Generally what happens, testing process also continues after the product is released. Something is found after the product is released, then it is called a defect. Else there is nothing difference between a bug and a defect. Both are same. Only difference is the time frame in which you are finding it. Okay, clear? Verification versus validation. I don't think many people have gone through this during their ISTQB preparations and during normal software engineering process. So verification is nothing but what you are doing, you are checking whether you are building the product right. In validation, you are checking whether you are building the right product. In verification, the process is emphasized. In validation, the product is emphasized. In validation, you are checking whether the product you are designing or whether the product you are developing, it is matching the requirement specification sheet correctly or not. But verification checks whether you are following proper standards or not, whether you are following proper nomenclature or not, whether you are following proper testing process is there or not. That thing is taken care during the verification process. Okay. Now, one important thing, how do defects arise in the process? You can see in requirement 1, it says correct requirement is in place. Then proper design was there to meet the requirement. Then that design was converted into a design, you can say a proper product. Then products work as expected. The first one is a classic example where everything is in place, nothing goes wrong. In the second one, you can see the requirement is correct, the design is also correct, but while the design was implemented in a build, there is a defect. The product has bugs in it, which results in bugs in the product. In the third thing, the defect is introduced in a little earlier stage, where the requirement is correct, but the design is incorrect, which results in an inappropriate build, and finally the result is what? The product is having issues. And the fourth one is you are having issues from the very primitive stages, that is requirement. Like the person who is actually gathering the requirement, he is not able to gather the requirements correctly. So that definitely will be passed on in the other phases, and it will finally result in a faulty application or faulty product. Okay. Now, the cost of fixing those things, it rises exponentially. The later you find the defect, the more is the cost. The early you find the defects, it is that much easy to fix, and it will also incur less amount of cost. It is pretty self-explanatory. Okay, so we always should be careful about good testing so that we find issues in the earlier part, so that fixing them will be less expensive. Okay. Then testing principles. All of you must be knowing like why we test, because testing shows presence of defects. But it cannot prove that there are no defects. Like no application can be completely bug free. Okay. Exhaustive testing is impossible. Like we discussed, you cannot test all the possible combinations. Okay, if you are given, like I have given an example of a key or a lock with different combinations, you cannot test all the combinations. How many permutation combinations are you going to try? There will be some path or some combination which will be left, and that might be found out by a customer while testing it. Okay, that is the reason we have these incidents. It's not like whenever something is tested good in a better manner and it is delivered, after that it doesn't get bugs. It gets bugs because someone who is using that, he might have followed some other way or some other path in which he has found a defect. Okay. Early testing. This is something we discussed just now. Like the earlier you find the bugs, the easier or the less expensive it would be to fix. So it is always advisable to go for early testing. Defect clustering. Do you know what is defect clustering? No? Any idea about defect clustering? What happens generally, you will find in particular applications, there is a chance of getting defects or similar kind of defects around a particular module. A small number of modules contains most of the defects discovered during the pre-release testing or show the most operational failures. It's a characteristic of the application. You will find the similar kind of defects around the same module, or there will be some modules which will be having the more number of defects. So in that case, you can say those defects were clustered around those modules. Getting my point? So that is why if you concentrate on those modules, your chances of getting bugs are more. So you can find more number of bugs which can be fixed to make the application better. That is called defect clustering. Okay. Pesticide paradox. Anybody knows what is pesticide paradox? Okay. The very classic real life example is a mosquito sitting on a mosquito coil. You take an application, run the same set of test cases, run the same set of tests time and again and again and again. After a few days, that application will be immune to those tests. Means if you are using the same tests, you will not be able to find any new bugs. There will be bugs, but your testing process is inefficient. It is not sufficient to find out those bugs. If you change your approach, if you change the way you test, definitely you will be finding bugs. But if you use the same testing process for more number of days, your application will be immune. Just like a mosquito gets immune to the mosquito coil. You use good night for 2 months. Next, on the 61st day, mosquitoes will not go away. Change your coil. Make it all out. Mosquitoes will go away. Okay. So this is called pesticide paradox. Testing is context dependent. That is principle number 6. This is a pretty common thing. Like your testing should take care of the application in the application's way. Like you do not test a security application like you test one e-commerce application, right? The way you test the e-commerce application is completely different. When you test a security application, you have to follow certain testing methodologies. You have to emphasize on few things which you do not be emphasizing while testing an e-commerce application, right? So the complete testing process, it depends on the context. What exactly you are testing, what product you are testing, or what particular domain you are testing in. Okay, because each domain, each product, each context has something which needs to be emphasized and it has something which can be ignored. Okay, clear? Absence of error fallacy. What is this? Anybody has any idea? Absence of errors fallacy. This is something you are delivering me this, which is, let's say you are delivering me a marker, okay, which is working absolutely fine. There is absolutely no issue with it. It says it will work as a blue marker and yes, it writes in blue, but I don't need a marker. As a customer, I have demanded a pencil and you are giving me a marker. So even if you are giving me something which is completely bug free, if I don't want it, then it is useless, right? So even if you tell me the product which I gave you is completely free from errors or it is completely free from bugs, as it is of no use, then it is not good for me. That is called absence of errors fallacy. Even if the errors are not there in the application, that is not useful for the client. So to avoid this thing, you need to be very clear about the SRS, what exactly the client needs. Okay, clear? Then I will go through these fundamental test processes. You can see planning and control is one of the fundamental test processes where you plan how the testing process will be and how you are going to control it. Okay. So here you determine the test approach, like what approaches you are going to take, what policies you are going to implement, who will be the resources, those will be there in that particular process, and how test analysis and design task, test implementation, execution, evaluation, those things will be streamlined. Everything you will be doing in the planning and control phase. Okay. Here, one of the most important thing is to determine the exit criteria. You know what is an exit criteria? Anybody knows? The exit criteria says, Shipra, you can tell what is an exit criteria? Yeah. Pardon me?
I have a doubt in that one.
Okay, please ask.
Is that basic criteria? So you can.
Okay. So what happens in the exit criteria? You cannot go on testing and testing and testing forever, right? There should be certain exit criteria to release the product. One of the exit criteria can be when 90% of the bugs are fixed, we can release the product. 90% of the critical bugs are fixed, we can release the product. One more exit criteria can be when the SRS or the requirements are completely matched in the application and tested properly, we can release the product. So exit criteria is nothing. It is a criteria, or it says like if the application is having these attributes or these are the things which are met during the testing process, then we can stop testing. You exit the testing process. That is called exit criteria. Okay. Then the next fundamental test process is analysis and design. Okay. Here you review the test basis, identify the test conditions, design the test, and evaluate the testability of the requirements and system. You determine over here like how much testable the application is. Okay. And you design the test conditions. Okay. Design the test environment setup and identify any requirement infrastructure and tools. So here what you do generally, you set up the test environment so that your test process can start without any issues. Okay. Test implementation and execution. This is nothing but whatever you have done in your planning and control and analysis and design phase, you implement. Okay. So you actually implement, you actually test in this particular phase. Okay. Evaluating exit criteria and reporting. Like you evaluate whether the exit criteria you have set in the first phase, those are met properly or not, and you report. Here, reporting doesn't mean reporting of bugs. Reporting means coming up with a test summary. What you have tested, what are the bugs those have been found, how many of them are fixed, what are the critical bugs those were found, how many of bugs are deferred for the next release, etc. These are the things which you put in the test summary report. Okay. Then test closure activities. So here you actually check what are the things those you went through during the testing process, what are the things those are being left. You take a note of everything, and finally you say like, yes, the testing process for this particular sprint. In case of agile, it is a sprint. In case of normal testing process, it's a release kind of thing. Okay. So there you say, yes, these are the things we have gone through. So this is how we have closed the testing process now. Okay. Now, testing type versus testing levels. I'm going a little fast because I have to cover a lot of fundamentals, because in my subsequent seminars, I'll be taking you through little deeper into testing. Okay. Testing levels, you must have seen, you can say component testing, integration testing, system testing, and acceptance testing. These are the testing levels, different testing levels. Okay. But testing types, it is functional testing, non-functional testing, and structural testing. Okay. In functional testing, what you do, you can say it's more of like black box testing. Okay. It is more focused towards business process or requirements. Okay. It tests suitability, interoperability, security, accuracy, and compliance. What do you mean by compliance? Anybody knows what is compliance testing? No? Like when you are testing a healthcare application, there is something called HL7 standard. You know that? Whether the application which you are designing, is it matching some required standards or not? Okay. There is something like IEEE 829. Okay. ISO 9126. These are all standards. Whether the application matches those standards or not. Okay. That is where they are matching the compliance with a particular standard, which they have to. If you want to deliver a quality product, the product needs to match a standard which is there in the market. That is where you test the compliance, whether it is compliant, whether it is matching the compliance with the available market standards or not. Okay. In non-performance testing, you can include performance testing, load testing, stress testing, usability testing, maintainability testing, reliability testing, and portability testing. Can anybody tell me what is the difference between load testing and stress testing?
Load is something like providing a huge user base to find out that yes, my application is built up for that particular load.
Okay.
Simultaneously.
Okay.
Stress is something like will be putting the application under stress. Like suppose I can say like BVA analysis involved value.
Okay.
We can put that analysis into under stress testing.
I'll give you a classic example, real life example. Like let's say a piece of string, it is designed to take 10 kgs of load. Okay. So in load testing, what will you do? You will give exactly 10 kgs and see how the string is behaving. But in stress testing, what will you do? You will give 10 kgs, then you will make 10.5, then 11, 11.5, 12, 12.5, till the string breaks. Okay. So that is how you stress test, and you will be finding the breaking point. Okay. So this is the difference between load testing and stress testing. Okay. So whenever you find a bug, please remember this picture, okay, which says if you find a bug, report it. Bugs don't like to be forgotten. If you find a bug, get to know them. Bugs like to be understood. How it is going to be helpful? Because if you know, you can be familiar with similar type of bugs you will be finding in the application. If you find a bug, take a photo. Bugs like to keep memories of the occasion. This is something related to the screenshots. You take a particular screenshot of that particular issue. If you find a bug, get to know their mates. Bugs are socialites. This is something related to regression impact. Okay. If you're finding a bug in particular thing, if that is fixed, that can create another bug in some other module. Okay. If you find a bug, report it quick. Otherwise, bugs settle in and make a home for themselves. This is something related to cost of fixing up bugs. The later you report, the more difficult it will be to fix the issue. If you find a bug, be honest. Bugs don't like gossips. Be honest in the sense, if you found a bug in Windows, don't tell I have found it in Linux. Say that yes, I have found it in Linux. So I say that I have found it in Windows. Okay, give the exact information where you found the bug. That is what this point means. If you find a bug, note how you meet them. Bugs are romantics. Okay, you need to remember the steps to reproduce. What steps you exactly followed to get to this bug. If you find a bug, don't ignore it. That is the most riskiest part. The most riskiest in the sense, if you ignore a bug, that bug can lead to disaster. That bug can lead to other bugs also. Okay. So that's all about basics, what you should be doing in testing and what you should be doing with bugs. Any questions? No?
What is regression testing?
Regression testing. Yeah. In regression testing, what we do, generally what happens, regression testing is done after bug fixes. So in regression testing, what happens, let's say I have found a bug. I have reported it and that bug has been assigned to a developer to fix. So when the developer will fix that particular issue in the code, it might also be possible that that particular bug is fixed, but something else is broken. Generally what happens? Something gets broken in the depending modules, which are referring to the module in which the bug is fixed. So in regression testing, what we do, we check the bug which is fixed and also we check the modules which are dependent on that module, so that we make sure this particular bug fix has not broken anything anywhere else. Clear? Any other question? No? We would be happy to hear from you and would be happier to answer your queries. So this is my email ID, sudeep@mindfaresolutions.com. Anytime you have any issues, you can drop me an email in this, or else you can add me in Skype for any type of questions related to software testing. Okay. Thank you for your time and patient listening. Have a great day. I'm good. I'm from Bhubaneswar. Yes, sir. Idea. My natives are in Salipur, but we have been staying in Bhubaneswar for the past 30 years. More than that means I am born and brought up in Bhubaneswar. Thank you. See, if that is why I keep ମୁଁ ସେଇଥିପାଇଁ ମୋ ସେମିନାରରେ ବେଶୀ ପିକ୍ଚର୍ସ ଇନକ୍ଲୁଡ କରେ ଏଇଥିପାଇଁ କାରଣ ଏଇ ଜିନିଷ ତମେ ଯାଇକି ଲୋକଙ୍କୁ କହିବ ନର୍ମାଲି ୱିଦାଉଟ୍ ପିକ୍ଚର
seminar was very responsible, interactive. So that it attract the audience.
Okay, thank you.
Previously, you was attend to 9-11 days ago. It's a I'm testing whatever unit testing is about.
So development course, no? We'll be doing unit test. But if you know the testing concepts, you will be writing your code thinking like how the testers will try to break it, so that it will reduce the chances of getting bugs. That is something called TDD, test driven development. माने तमे चिंता करूछो जे गोटे डेवलपर हिसाब रे तमे या चिंता करछो जे गोटे टेस्टर जले एप्लीकेशन टेस्ट करिवो से कोन कोन अप्रोच नहीं पारे आको ब्रेक करिया तो तमे सेही जिंसडा का वैलिडेशन लगे लगे जी तो प्रोडक्ट जले बाहर हो टेस्टर जले ये करिवो टेस्ट करिवो सेही से इश्यूडा से पाइबो. ओके, वेलकम. Okay, good morning. This seminar will be basically focusing on for QTP, whatever tools we use, we write scripts to automate the softwares. Also, like you said, it is one of the biggest things that we cover under software testing is finding bugs, finding flaws in the application.